Ladies and gentlemen, I'm truly honored to welcome you all at the University of Warsaw for the presentation of the Włodzimierza Kołosa Medal. This year the medal is awarded to Professor Anna Krylov from the University of Southern California, Los Angeles, in recognition of her outstanding achievements. This medal is awarded every 2 years, and it honors exceptional contributions to the field of theoretical and physical chemistry, and it is presented jointly by the Faculty of Chemistry at the University of Warsaw and Polish Chemical Society. Today we are joined by 3 special guests: Professor Artur Michalak, Vice President of Polish Chemical Society, Professor Robert Kołos, son of Professor Włodzimierz Kołosa and respected chemist at the Institute of Physical Chemistry of Polish Academy of Sciences, and Professor Joachim Sauer from Humboldt University, 2009 laureate of Kołosa Medal. It is an honor to have you here. I would like also to warmly thank the Kołosa Medal Committee for the hard work in selecting this year's laureate. The committee's dedication ensures that Professor Kołosa's memory continues to inspire and that outstanding scientists are recognized for their achievements. Today's program will begin with Professor Michał Lesiuk, who will tell us about the life and legacy of Professor Włodzimierz Kołosa. Just a moment. After that, Professor Michał Tomza will introduce the scientific accomplishments of our laureate, Professor Krylov. And following these introductions, we will move to the awarding of the Kołosa Medal, and then we will have the pleasure of hearing Professor Krylov's lecture titled Molecular Orbitals, Physical Reality or Mathematical Construct. So thank you all for joining us to honor Professor Włodzimierz Kołosa and celebrate Professor Krylov's impressive work, and let this event inspire us and in all our pursuits for knowledge and excellence in chemistry. So thank you for joining us today.
Talent, passion, and the highest standard in science and science are characterizing Anna's work. She is a prime example of how a quantum chemist can build a successful research agenda that covers the electronic structure of systems ranging from simple atoms, single atoms, to biomolecules. This would be not possible without Anna's synergetic approach to theoretical research, which benefit from advances in other disciplines and at the same time is complementary to experimental discoveries. Professor Anna Krylov's achievements have already been recognized with numerous prestigious awards. I mentioned only Dirac Medal, but the list is very long, so I will stop and not mention all of them. And from today, that list has a new entry. The Medal of Włodzimierz Kołosa, awarded by the Polish Chemical Society and the Department of Chemistry, University of Warsaw, for her outstanding contributions to the theoretical chemistry of open shell and electronically excited molecules in complex environment. Dear Anna, please accept our congratulations on this new distinction and also our sincere thanks for all your fantastic contributions to our field of research. We wish you many further successes in your research and the continued joy of making amazing science.
Thank you very much for this rich introduction. As we could see, Professor Krylov is not just an excellent scientist, but extraordinary character in general, I would say. So at this moment, we will move to the presentation of the Kołosa Medal. So I will ask Vice President of Polish Chemical Society, Professor Artur Michalak. I will put this microphone for a while on site.
Professor Kołosa was a true pioneer of quantum mechanics, and I remember hearing about his work and his name and the famous Kolos-Volnievich predictions when I was an undergraduate student at Moscow State in the, I believe, first class on quantum chemistry. We were told about that. I am really humbled to receive a medal in his name. So let us consider photo detachment or photoionization experiment. Let's start with closed shell system, and then we kick out one electron and put it in the continuum. So can we use molecular orbital concepts to describe this? Well, let me show you a few equations, and they are related to the experimental, what we see experimentally. So the key object that is related to experimental measurement here is this matrix element, which we call photoelectron matrix element. Now, orbital reconstruction is possible, but with caveats, and some of these experiments are still considered to be controversial, but I think it is possible, maybe not perfect. So to conclude, I would like to thank people who did all the work, my current group, including Pavel, who is about to graduate, and a stellar team of former students and postdocs whose results I showed today, Koshik Nanda, who is now in QCAM, Pavel Pohilko, now with Dominikas Git in the University of Michigan, Wojtek Skamarowski, who is here at Warsaw, Samir Gozem at Georgia State University, Thomas Yagau, KU Leuven, Ksenia Bravo at BU, and Mark de Vergifosse at also Leuven, but other half of it. And finally, I want to get back and to Kolos, and I want to say a few words about inspiration he provides to scientists today. We heard a lot about his remarkable scientific achievements and his pioneering work, which is true. But he also was a man of courage and integrity. So here is a quote from this short but very nice article about him, which says, "In the years of communist power in Poland, Wlodek never compromised his political and moral standards. Neither Wlodek nor anyone in his group was ever a member of the Communist Party, an unusual situation in those years." Now, it wasn't just unusual. It really required moral courage, and it could have serious career consequences. Now, many people living in this time in different countries under socialism rule were less brave and choose to compromise and collaborate with the regime. Now, we do not want to judge them because we do not know how it was. Well, we know, but we do not want to judge them, but I want to emphasize that we should take inspiration from people who didn't compromise, from people like Kolos, and draw inspiration for today. And inspiration we need, because today we see, unfortunately, the return of the same old illiberal ideas, Marxism, Leninism, that comes back, slightly repackaged and renamed as critical social justice or diversity, equity, and inclusion. And we see how these ideas are being propagated and subverting science. And in order to oppose them, we need courage. And I hope that we will get courage by being inspired by Kolos' life, remarkable life and achievement. Thank you.